The hinge is represented by the red spot that I will give you, okay? So that means that this object is about to rotate like this or like that, okay? Like this or like that. That's it, okay? Because this is the hinge. This part of the object is not moving. Now, that's not what I wanted to show you. I will apply several forces on this beam. I'm going to apply a force here. I'm going to apply a force over there. I will apply a force here, and I will apply another force at an angle, okay? Okay, so analyze this. In this case, it's a column, okay? Analyze this column. If I apply a force, I will call this force to be 1. Am I going to create rotation? Hold the pencil from the eraser in the position of the hinge. Are you creating rotation? Is rotation produced by the force 1?
Yes.
So you analyze, and after you do that, you say, okay, force 1, yes, it's creating a rotation, and you can pull the rotation like this and negative, okay? But I'm not asking you to do that yet. Right now, I just want you to tell me if rotation is produced. For the force 2 applied to the right, it's going to produce rotation, yes or no? Again,
Yes.
Yes.
grab your pencil, and yes, you can see rotation is produced. So you can conclude that force 2 also produces rotation. Now I'm gonna work with the force 3 that I have in the bottom here, like that, okay? So grab your pencil from the eraser, and what type of force are you going to apply? Pushing or
Pulling.
pulling?
Pulling.
So you're going to pull the pencil, and you will tell me, is rotation produced? Yes or no?
No.
Produce.
So the force 3 is not producing rotation. Now, today we're going to focus on this type of forces, okay? Forces at an angle. Like you saw last year, what we did last year, and when I taught you about vectors, we had angles everywhere, okay? And then we saw motion in two dimensions, projectile motion. The first step was getting components because we had an angle. So for this type of problems, for torque, you're gonna be doing the same. You're gonna be analyzing the forces at an angle, and you will tell which one of the two components creates the rotation, the X or the Y component. So how do we work on this? I'm gonna be giving you different forces in different directions, okay? This one is going southeast for that saying. So what you do to make it easier for that saying is you complete a triangle. I do it like this. For the component, what component will be this one? Could be component in X or component in Y.
In Y.
So this, which is the force, I'm going to call this force 4, okay? So this is going to be force 4x, y, sorry, and then I will do the same for the other component. This force is going down, but also to the right. So I have the components, the one that is going down and the other that is going to the right. Now, from the two components, which one produces torque? Y or X?
X.
So for Y, it's not producing a torque, but for X, it does. So that is the kind of analysis that you are going to be doing for this type of exercises. Now, I'm going back to this is going to be part of the homework for you to get ready with the components and vectors, okay? But now I will explain you one exercise that has angles. So for this one, we're also going to analyze with a pencil. The pencil is very useful, guys. So when I say that the pencil is a good way to learn, use it, okay? It's there for a reason. Use it, it's just a tool. Now take a look here. It says calculate the torque for each force acting on the bar. Assume the axis is perpendicular to the page and passes through the point O. In what direction will the object rotate? So here the problem is telling me first that I need to calculate the torque for each force. That is the first indication, okay? Then the second indication is assume the axis passes through the point O. That's the other information it gives me, where the axis of rotation is located. It is in the point O, and then it asks me, it's not asking me about the net torque, okay, but we're going to get the net torque to see, or just to answer the question, that is, in what direction will the object rotate? So first of all, what we do is we mark the position of the hinge, or the position of the axis of rotation. That one is right here. I'm gonna put it in red. Okay, that is my axis of rotation. So let's analyze the first force. I'm going to call this force force 1. I'm going to call this force as force 2. And I'm going to call the force of 10 Newton force 3. Okay. Now, I'm going to take my first force and I will represent the components. Okay. So for this force, I will have my component in X right there. No me gusta cómo se mira. Wait. Más o menos. Bueno, ahí se queda. So this will be for me my component in X. Okay, so I'm going to call this F1X. Now for my component in Y, I will do the same. Take a look. No puedo, no sé. No sé por qué se pone así de tonto. Let me see something. I know the reason now. Okay. Now take a look. I can construct or I can represent my component. Wait. There. Okay. I can do that. This is going to be for me, my force 1, but in y-axis. Now tell me one thing. The force 1 in x, is it going to create rotation?
No.
So grab your pencil from here. Okay, and then the force that you will be applying is to the left. So are you creating rotation? As you said, no rotation is produced. Okay, no rotation is produced. So apply the force. You can see no rotation is produced. So we're going to get rid of this. We're not going to work with that because it's not doing rotation, it's not doing torque. Now, for the F1Y, tell me, is rotation produced? Remember, you hold the pencil from the eraser, and now you're going to push it down. Where? In the position of the eraser, because that is the position where you are applying the force. Are you rotating the object?
No.
No. Rotation doesn't occur here neither. So what you can see here, and that's why I'm going to write this beside, is forces applied on the axis of rotation don't produce torque. You saw that, okay? That neither one way or the other, the object was not rotating. So, in other words, you can also say that force on the axis or on the hinge, forces on the hinge won't be considered, okay? To get that torque. Okay, I can say it in words, but I show you with a pencil, okay? I show you with a pencil that no rotation will occur. Now, we already finished with the force 1, so we're going to continue with the force 2. The force 2, I can get the components. Again, I can get the components. So, I'm going to do, the components are gonna be here. The component in X, and here, the component in Y. Which one of the two forces produce rotation? Gray or green?
Gray.
Gray is producing rotation, so this one, okay. This one produces the rotation. So this one here, no. Now, what is this force? How do we name that force? Is it the component in X or the component in Y?
Y.
So it is F2 Y. That is how we're going to call it. Remember that forces need a name. Put this here. Okay, we need to zoom in a little bit. Now, how is this force according to the angle? Is it touching the angle or is it in front of the angle? How can I get this component?
It's touching the angle.
Touching the angle. If it touches the angle, what trigonometric function do you use? Do you use sine or do you use cosine?
Cosine.
Cosine, when touching the angle, you're gonna be using cosine, okay? So for this force, 2, you're gonna be using cosine, like that, okay? This is just a prior analysis. We're not solving anything yet. So now that we move from the force 2, we know already where it is located. We know already what is the force that is causing the rotation. And we know already what is the trigonometric function to get the component. So now we're going to move to the force 3 right there. We're going to be doing the same. We're going to be doing the same. So for this force, I will put the components, okay? The component in X and the component in Y. Now this one is a little bit more complex. So I'm going to zoom in, okay? We're in this part only. Now tell me, which of the two forces are doing the rotation? Gray or green?
Gray.
So gray is doing the rotation. I'm gonna put a mark over there. So I won't consider this component. And now the question is, how is this force, the gray force, according to the angle? Is it next to the angle or is it in front of the angle?
In front.
It is in front, yes. How in front? How do I know that? Take a look what I'm gonna do. The other force that I just draw is the same force that I did before, okay? They have the same size and they go in the same direction. So they are both the same force. If I put another force right here, I will see that these two are twins, okay? They are twins, so I know that two of them, the two greens, they are not making any torque. But today, I'm going to work just with these other twins, the two other forces. This force right here, which is the twin, you can see that is how, according to the angle, it is in front. So, because these two are twins, they are the same force, they go in the same direction, you know that the force itself is in front of the angle. If it is in front of the angle, what trigonometric function do we use to calculate the component?
Sine.
Sine. And that is because this angle right here is the same angle right here. And again, as you can see, it's in front, okay? This angle here is the same here. Remember that. You see that in math, okay? Those are known I forgot the name already. I taught it to you in 8th grade and I forgot the name since I don't teach math anymore. So take a look here. You already saw that this force, the great force, is going downward and is in front of the angle. The angle is here, but also it's the same than here, okay? So because it is in front of the angle, this component is going to be using sine. Now, how is that component? Is that component in X or component in Y?
In Y.
Y.
So you have the name already, okay? So I'm going to put this like that. Okay, this is just the prior analysis. After you do that, you're going to do the first step, that is building or constructing a free body diagram. Free body diagram. How is this going to look? I'm going to trace a bar in the exact same size of the given one. Okay, that's the bar. Maybe slightly bigger. And I'm going to put my hinge over there. And I will include only the force that are doing torque. Okay, only the forces that are doing torque, which is this one up, that's one, and the other one that is this one down, like that. After I put the forces, I'm going to name them. This is F2Y and this is F3Y. After I name it, I'm going to put the lever arms. Okay, I'm going to put the lever arms. So this will be my first lever arm. That measures 2 meters. And now the last lever arm that measures 4 meters. That's my free body diagram. That's everything I have. Okay. Now, I need to know what my components are. So that is going to be my second step. My second step is components. So I'm going to get F2Y and F3Y. You already know what trigonometric function to use since you already put it here. In 1, you're going to be using sine in the 3, and in the number 2, you're going to be using cosine. So this F2Y is just the force 2 times cosine of the angle, which is 31. And F3Y, it's going to be the force 3 times the sine of the angle, that is 23. So this is equal to F2. F2 is going to be equal to 25 cosine of 31. How much is this?
21.43.
And the F3, it's going to be 10 times the sine of 23 which is
3.90.
3.9.
9.
Okay, now that you have the forces, you're going to put it in the free body diagram. I'm going just to substitute by the numbers. Okay, so this is 23. And this is 21.43 Newton. And this is 3.9 Newtons. After you get that, you will do the following step. That is calculating the torques. Okay, you will be calculating the torques. I'm gonna do it beside here. In your notebook, you're gonna put it in order, okay? The torques. So the torque 1 is equal to, the torque 2, torque of the force 2 is going to be equal to the force 2 in y times the distance. And the other one is torque 3 is equal to the force 3 in y times the distance. You replace by the givens, and you will have 21.43 times Newton times the distance. That is 2 meters. How much is this?
42.86.
42.86.
And now for the torque 3, it's going to be 3.9 Newton times the distance, that is 4 meters. How much is this?
15.6.
Now you indicate the rotation of the torque to the rotation is positive or negative?
Positive.
It's going to be positive, and positive rotation is counterclockwise. The torque 3, positive or negative rotation?
Negative.
Negative rotation or clockwise. Now that you have the torques, you have to get the net torque. That is just adding them, okay, or subtracting them. So it is going to be positive 42.86 Newton meter minus 15.6 Newton meter. How much is that?
27.26.
27.26. Positive or negative?
Positive.
If it's positive, it's counterclockwise. So in what direction will the object rotate? The